Light by Kayla, Jordan, and Jake.
This is the electromagnetic spectrum. It illustrates the spectrum of light waves, with waves with long wavelengths and low frequencies on the left, and waves with short wavelengths and high frequencies on the right. There are two types of light rays, polarized and unpolarized. Unpolarized light moves in many directions, while polarized light moves in a single plane. You can make unpolarized light polarized by shining it through a polarizing filter. A polarizing filter only lets through light waves moving parallel to the transmission axis. In the first set of filters, where both are parallel to each other, the light waves would be the same after going through the first filter as they are after going through the second filter. In the second set of perpendicular polarizing filters, almost no light would pass through the series of filters. This is illustrated with the picket fence analogy, which illustrates light waves moving through parallel and perpendicular polarizing filters.
The spectrum of visible light has a range of wavelengths which correspond to different colors. There are 7 component colors of visible light. The color we see is a reflection of light off of objects. Different objects can absorb different wavelengths of light, and any light not absorbed by an object is reflected. The color of the reflected light is what we perceive to be the color of the object. When all colors are reflected, the object appears white. When all colors are absorbed, it appears black. Transparent materials allow one or more colors of light to be transmitted through them. Their appearance depends on the colors of light that are transmitted. Primary colors of light are 3 colors that, when mixed together with equal intensity, appear white. The most common set of primary colors is red, green, and blue. If 2 primary colors are combined with equal intensity, a secondary color is produced. Complementary colors are 2 colors of light that produce white when combined in equal intensities, so magenta and green are complementary colors. The color of light you shine on an object can change the color you see. If you shine a yellow light on a magenta paper, the paper will appear red. It is important to think about the colors that an object will absorb in order to figure out what color the object will appear.
According to the law of reflection, the angle between an incident ray, or the ray of light moving towards the surface, and the normal line will always be equal to the angle between the normal line and the reflected ray, the ray of light reflected off of a surface. There are 2 types of reflection, specular and diffuse. Specular reflection, also known as regular reflection, is off of smooth or even surfaces like glass, mirrors, and calm water. Diffuse reflection are off of rough surfaces. Smooth surfaces reflect images uniformly, which is why you can see a perfect mirrored image of a mountain on the surface of a calm lake. On rough surfaces, each individual ray hits a differently sloped and angled surface, so each ray is reflected in a different direction. So when driving at night, your headlights reflect diffusely off of the pavement, creating the sparkly effect you see on the road.